Personal protective equipment. Terminology. Personal protective equipment is protective clothing, helmets, goggles, or other garments or equipment designed to protect the wearer's body from injury of infection. The hazards addressed by protective equipment include physical, electrical, heat, chemicals, biohazard, and airborne particulate matter. Protective equipment may be worn for job-related, occupational safety and health purposes, as well as for sports and other recreation activities. Protective clothing is applied to traditional categories of clothing, and protective gear applies to items such as pads, guards, shields, or masks, and others. PPE suits can be similar in appearance to a clean room suite. The purpose of personal protective equipment is to reduce employer exposure to hazards when engineering controls and administrative controls are not feasible or effective to reduce this risk to acceptable levels. PPE is needed when there are hazards present. PPE has the serious limitation that it does not eliminate the hazard at the source and may result in employers being exposed to the hazard if the equipment fails. Any item of PPE imposes a barrier between the wearer user and their working environment. This can create additional strains on the wearer, impair their ability to carry out their work, and create significant levels of discomfort. Any of this can discourage wearers from using PPE correctly, therefore placing them at risk of injury, ill health, or under extreme circumstances, death. Good ergonomic design can help to minimize these barriers and can therefore help to ensure safe and healthy working conditions through the correct use of PPE. Practices of occupational safety and health can use hazard controls and intervention to mitigate workplace hazards, which pose a threat to the safety and quality of life of workers. The hierarchy of hazard controls provides a policy framework which ranks the types of hazard controls in terms of absolute risk reduction. At the top of the hierarchy and elimination and substitution, which remove the hazard entirely or replace the hazard with a safer alternative. If elimination or substitution measures cannot be applied, engineering controls and administrative controls which seek to design safe mechanisms and coach safer human behavior are implemented. Personal protective equipment ranks last on the hierarchy of controls as the workers are regularly exposed to the hazard with a barrier of protection. The hierarchy of controls is important in acknowledge that while personal protective equipment has tremendous utility, it is not the desired mechanism of control in terms of worker safety. Yearly PPE, such as body armor, boots, gloves, focused on protecting the wearer's body from physical injury. The plague doctors of 16th century Europe also wore protective uniform consisting of a full-length goggles, a helmet, glass ear coverings, gloves and boots, see a plague doctor costume, to prevent contagion when dealing with plague victims. These were made of thick material which was then covered in wax to make it water resistant. A mask with a big-like structure was filled with pleasant smelling flowers, herbs and spices to prevent the spread of miasma. The prescientific belief of bad smells which spread disease through the air. In more recent years, scientific personal protective equipment is generally believed to have begun with the closed face mask promoted by William Tich in the 1910-11 Manchurian pneumonic plague outbreak. Also, many Western medics doubted the efficacy of face masks in preventing the spread of disease. Types. Personal protective equipment can be categorized by the area of the body protected, by the types of hazard, and by the type of garment or accessory. A single item, for example, boots, may provide multiple forms of protection. A steel toe cap and steel in clothes for protective of the feet from crushing or puncture injuries. Improves rubber and lining for protection from water and chemicals. High reflective and harsh resistance for protection from radiant harsh, and high electrical resistivity for protection from electric shock. The protective attributes of each piece of equipment must be compared with the hazard expected to be found in the workplace. More braceable types of personal protective equipment may not lead to more contamination but do result in greater user satisfaction. Respirators serve to protect the user from breathing in contaminants in the air, thus preserving the health of their respiratory tract. There are two main types of respirators. One type of respirator functions by filtering out chemical and gases, or airborne particles from the air breathed by the user. There are two main types of respirators. One type of respirator function by filtering out chemicals and gases or airborne particles from the air breathed by the user. The filtration may be either passive or active, powered gas mask and particular respirator like N95 masks are example of this type of respirator. A second type of respirator protects users by providing clean, respirable air from another source. This type includes airline respirators and self-contained breathing apparatus. Invoke environments respirators are relied upon when adequate ventilation is not available or other insurance control systems are not feasible or inadequate. In the United Kingdom, an organization that has extensive expertise in respiratory protective equipment is the Institute of Occupational Medicine. This expertise has been built on a long-standing and varied research programs that has included the setting of workplace protection factors to the assessment of efficacy of masks available throughout high street retail outlets, the Health and Safety Executive, Health Scotland and Health Working Leaves have jointly developed the APA selector tool, which is web-based. This interactive tool provides description of different types of respirators and breathing apparatus, as well as a dozen don'ts for each type. In the United States, the National Institute for Occupational Safety and Health provides recommendations of respirator use in accordance to INEASH Federal Respirators Regulation 42 CFR Part 84. The National Personal Protective Technology Laboratory of NIOSR is tasked towards actively conducting studies on respirators and providing recommendations. Surgical masks considered a PPE but are not considered as respirators, being unable to stop submicron particles from passing through and also having unrestricted airflow at the edges of the masks. Elastomeric respirators, also called reusable air breathing respirator, sealed to the face with elastomeric material, which may be a natural or synthetic rubber. They are generally reusable. Full-face versions of elastomeric respirators seal better and protect their eyes. Elastomeric air purifying respirators are reusable because the face piece is cleaned and reused, but the filters are discarded and replaced when they become unsuitable for future use. Some, but not all, filter materials are proprietary and manufacturer specific, and supply chain failures can make replacements hard to find. Also, powered air purifying respirator and air supplying respirators may have elastomeric masks. They are not generally referred to as elastomeric respirators. Elastomeric respirators are examples of air filtering respirators in contrast to air supplying respirators. Air supplying respirators are usually positive pressure so they leak outwards and thus offer better protection. They are more complex and heavier, but less bulkier about the head and can be worn for longer. Air purifying respirators draw the surrounding air through filters, which remove contaminants. A range elastomeric are used including silicone, neoprene, EPDM, ethylene propylene, monomer rubber, or proprietary elastomers such as Hycar. Latex is rarely used due to allergies. Many manufacturers offer a choice of two materials. Elastomeric respirators include mouth-bit respirators, which fit in the mouth with the nose punched should escape only quarter mask or in nasal mask, converting the mouth and nostril only half mask from below the eyes to below the chin. Full face mask from above the eyes to below the chin. Air purifying respirators have filters. The masks and filters come in a variety of standards for mechanical filters and for chemical cartridges. Intended for a variety of purposes, an appropriate standard of filter must be used for the mask to be effective. Filters may be contained in cartridges or canisters. There are also flexible, flat and pancake style filters. Filters are usually mounted on the face, but in the case of powered air purifying respirators, they are mounted on the belt and fan dryers. I throw them and into the face mask. Most masks take one or more filters. Air purifying respirators cannot be used in oxygen deficient atmospheres, less than 19.5% oxygen. Nor can they be used in atmosphere with a contaminated concentration that may be immediately dangerous to life or health, or in unknown atmospheres. In these cases, air supplying respirator must be used. if concentration of hazardous particles or gases that are greater than the occupational exposure limit. US regulations require that respiration be worn, but they may also be worn at lower concentrations. Similar mandatory legal requirements apply to employers in many other countries. The respirators must have a sufficient assigned protection factor for the conditions. Elastomeric masks may fail to protect if they are not donned before investigating a funny smell. They will not protect if they are kept far away or in fiddly packaging so that they cannot be donned within a single breath when a problem occurs. They will not protect if they use without practicing being unable to breathe, panics and attempts to run further than don the respirator. Other problems include using a size other than the size that was fit tested on, using the wrong sort of cartridge, reusing a cartridge that is no longer good, not doing a positive and negative pressure seal check each time the mask is donned, failing to test the respirator and perhaps inhaling the carbon from a broken cartridge, and even putting the nose clip up the nose rather than using it to pinch the nose shoot. Fit is critical to the protection provided by a elastomeric respirator. Elastomeric masks must be individually fit tested and inspected for full efficacy. There may be some way easier to fit the filtering facepiece respirators. Older mask designs were designed only to fit young adult men of average weight and a narrow range of ethnics. Never once use updated anthropometry and fit more people. Limited research suggests that elastomeric respirator may have a better fitting characteristics than disposable filtering face respirators, fitting a broader variety of faces and thus being more likely to seal well when the user has not done a formal fit test. Available evidence also suggests that as a class, elastomeric respirators may leak less, and their seals are less likely to become damaged. Elastomeric respirators have wider straps which slip less, individually adjustable straps, and wider, softer, more flexible seals. See image below. This may help reduce leaks. Full-face elastomeric respirators generally seal better for substances hazardous to the eyes. Respirator equipment with a full face space, helmet or hood is recommended. Eyeglasses can clash with elastomeric masks Conventionally, full face masks are modified with prescription lenses inserted into the mask. Glasses can be worn over a half mask as long as they do not interfere with the seal or heat straps. Some users find this uncomfortable. Wearing contacts is not possible where there is a risk of solvent vapors and may not be visible if there is an infection risk, but otherwise contacts can be worn. Facial hair underneath the seal is also a problem. Piercings, jewelry, heavy cosmetics, and some creases and scars can also interfere with sealing. Straps may stretch slightly over time on some models. Communication. It is harder to understand the speech of someone wearing most types of elastomeric respirator. This can be dangerous in some environments. Some commercially available respirators include sound transmitting diaphragms and or transparent windows giving a view of the mouths to improve communication efficiency. Designs that allow the jaw to move more freely may also help. Electronic voice relays from inside the mask or from a throat microphone have also been used. Elastomeric respirators without this modification muffle the various speech more than filtering face-piece respirators such as N95 respirators. In some studies, this was a major reason why healthcare workers prefer to wear FFRs. Many are perfect respirators without air supply provide the workers with clean, perfect air with an excessively high concentration of carbon dioxide. For example, in the USA, the permitted exposure limit for dioxide CO2 is half percent by volume, our each hour shift, and 1.4% by volume over any 15 minutes period. But value measured for elastomeric respirator can increase to 2.6%. There is a lack of studies on the oxygen and carbon dioxide levels in the dead space behind an elastomeric respirators, but this may also cause headaches, especially if worn continually for 4 hours. Sweat does not evaporate as easily from under a mask. Elastomeric respirator may be more hot and humid than FFRs. However, respirators cause more fatigue. More breathing resistance causes for fatigue, and mask makes the wearer more likely to feel out of breathe, or claustrophobic. These tight straps on any type of respirator are reported to put pressure on the sinus and causes headaches. Users first responders may use costumeric respirators, including during smoke simulation exercises. Air purifying respirators are not effective during fighting in oxygen deficit atmosphere or in an known atmosphere. In this situation, an air supplying respirators such as self-contained breathing apparatus is recommended instead. Gas masks are extensive used in mining and construction. They are used against paint, rare vapors, solvents, silica dust, and other hazardous particles and gases. Masons and carpenters use them against dust and adhesives. Costumeric respirators may be used to protect against welding fumes. Different welding processes may produce different fumes, dust, particles and gases such as carbon monoxide, oxygen displacement by otherwise harmless sharing gases is also a risk. Self-contained breathing apparatus may be needed. Respirators used by welders must fit under a welding mask. A self-contained breathing apparatus, sometimes referred to as a compressed air breathing apparatus or simply a breathing apparatus, is a device worn to provide breathable air in atmospheric that is immediately dangerous to life or health. They are typical used in firefighting and industry. The term self-contained means that the SCBR is not dependent on a remote supply of breathing gas. If designed for use underwater, it is also known as scuba set. When not used underwater, they are sometimes called industrial breathing sets. Unofficial names include air pack, air tank, oxygen cylinders, or simply pack, which are mostly used in firefighting. A self-contained breathing apparatus may fall into one of two categories: open circuit or closed circuit. The closed circuit type, also known as a rebreather, operates by filtering, supplementing, and recirculating exhaled gas. It is used when a longer duration supply of breathing gas is needed, such as in mine rescue, and is in long tunnels and going through passages too narrow for a big open circuit air cylinder. Before open circuits were developed, most industrial breathing sets were rebreathers, such as the Cyber-Gorman Proto, Cyber-Gorman Savox, or Cyber-Gorman Salivus. An example of modern rebreathers SCBS would be the SEFI. Open circuit Industrial breathing sets are filled with filtered, compressed air rather than pure oxygen. Typical open-circuit systems have two regulators. A first stage to reduce the pressure of air to allow it to be carried to the mask, and a second stage regulator to reduce it even further to a level just above standard atmospheric pressure. Air is then fed to the mask via either a demand valve or a continuous positive pressure valve. An open circular reservoir of five fighter CBI has a full-phase mask regulator, air cylinder, cylinder pressure gauge, remote pressure gauge, and harness with adjustable shoulder straps and waist belt which lets it be worn on the back. The air cylinder usually comes in one of three standard size: 4 liters, 6 liter or 6.8 liter. A CBI pack with pass device air cylinder made of aluminum, steel, or of a composite construction, usually carbon fiber wrapper. The composite cylinders are the lightest in weight and are therefore preferred by fire departments, but they also have the shortest life span and must be taken out of service after 15 years. A cylinder must be hydrostatically tested every 5 years. During extended operation, empty air cylinder can be quickly replaced with fresh ones on the refilled from larger tanks in cascade storage systems or from an air compressor brought to the stands. Open circuit SCBAs use either positive pressure or negative pressure operation. A negative pressure system relies on the internal pressure of the mask dropping to below the ambient pressure to activate flow. If the mask does not seal perfectly, some leakage of ambient gas into the mask will occur, which can be a problem with toxic or irritant smoke and fumes. A positive pressure system slightly pressures the interior of the mask and activities flow when the pressure difference is reduced but still above ambient. If the mask leaks, there will be a continuous flow to maintain the pressure and no inward leakage is possible. With a good fit, this is economical on gas and prevents contamination. If the mask falls off, the regulator will continually expand gas, trying to raise to the pressure, and may consume a significant amount of gas before it is corrected. Also, the performance of both types of SCBI may be similar under optimum conditions. This fail-safe behavior makes positive pressures SCBA preferable for most applications, as there is usually no usage penalty in providing positive pressure. The older negative pressure type is in most cases an obsolete configuration, and it is only seen with older equipment. However, some users refuse to use this technology, as in case of damage or loss of the facepiece, their air will be released and controlled. The leakage rate can be so high that a fully charged SCBR will be drained in less than 3 minutes, a problem that does not happen with negative pressure SCBA systems. The full face mask of bracing apparatus designed for use out of water are sometimes designed in a way that makes them unsuitable for scuba diving. Also, some may allow very shallow emergency submersion. The seal at the edge of the mask is a wide tube with the flexible balls running around the edge of the mask, full of air at atmospheric pressure. On the surface, it pushes against the edges of the wearer's face, causing a tight seal despite small variations in its shape. At more than a 5 feet depth pressure, this tube collapses, destroying the seal and making the mask leak. Masks curved window, which underwater would severely distort the image by refractions. The mask can have a large viewport or small eye lenses. The mask might have a small orinasal bracing mask inside, reducing bracing dead space. The mask can also incorporate a two-wave radio communication. Some early industrial rebracers had a multiple mouthpiece and attaches not a clip in straight of a mask. There are two major application areas for SCBR: fight fitting and industrial use. A third use now coming into practice is medical. For example, is the American National Institute for Health perceive use of SCBR for medical staff during treatment of Ebola. This mask is not SCBA's. For firefighting, the design emphasis is on heat and flame resistance above cost. SCBA designed for firefighting tend to be expensive because of the exotic materials used to provide the flame resistance and to a lesser extent to reduce the waste penalty of the firefighter. In addition, modern firefighting SCBA incorporate of pass devices or an ADCU into their design. These units emit distinctive high-pitched alarm tones to help location fighters in distress by activating if movement is not sensed for a certain length on time, also allowing for manual activation should be need areas. In fighting use the layout of the breathing set should not interfere with ability to carry a resuited person over the fighter's shoulders. Their other major application is for industrial users of various types. Historical meaning was an important area, and in Europe this is still reflected by limitation on use in the construction of SCBAs of metals that can carry sparks. Other important users are petrochemical, chemical and nuclear industries. The design emphasizes for industrial use depends on the precise application and extends from the bottom and which is cost critical to the most severe environment where the SCBA is one part of an integrated protective environment which includes gas ties, suites for whole body protection and user of decontamination. Industrial users will often then be supplied via an air line and only carry compressed air for escape or decontamination purposes. Skin protection, occupational skin disease, diseases such as contact dermatitis, skin cancer and other skin injuries and infection are the second most common type of occupational disease and can be very costly. Skin hazards which lead to occupational skin disease can be classified into 4 groups. Chemical agents can come into contact with the skin through direct contact with contaminated surface, deposition of aerosols, immersion or splashes. Physical agents such as extreme temperature and ultraviolet or solar radiation can be damaging to the skin. Over prolonged exposure, mechanical trauma occurs in the form of friction, pressure, abrasion, laceration, and contentions. Biological agents such as parasites, microorganisms, plants, and animals can have varied effects when exposed to the skin. Any form of PPE that acts as barrier between the skin and the agents of exposure can be considered skin protection because much work is done with the hands. Gloves are an essential item in providing skin protection. Some examples of gloves commonly used as PPE include rubber gloves, cut resistance gloves, chainsaw gloves, and heat resistant gloves for sports and other recreational activities. Many different gloves are used for protection, generally agents mechanical trauma. Other than gloves and any other article of clothing or protection for a purpose serve to protect the skin. Lab coats, for example, are worn to protect against potential splashes of chemicals. Face shields serve to protect one's face from potential impacts, hazards, chemical splashes, or possible infection fluid. Thank you for your listening. Goodbye.